Welcome back to our lab session number 8 in socket programming in C. Today what we will be talking about is manipulating socket characteristics. Alright, so what we'll be trying to do is setting and getting socket characteristics. So whenever you want to create a socket, you can modify some of the socket specific characteristics, such as if you remember the TCP's internal buffer size, or keep alive, or time to live, how many hops it can go until it reaches the destination. And there are a lot of properties that we can change, and you can see a lot of example characteristics on this table. And so the things that we have to know to be able to change the socket characteristics are the level of the characteristic on the protocol, so that's called the protocol level, and then the name of that option. And also we have to know which of the options it can be modified by our program and which of them cannot be modified. So these protocol level constants, which are given here, are used as arguments for a function called setSockOption and getSockOption, which I will show a little bit later. So let's try to understand what are these the constants. The first thing is the level of the protocol, the level of the property that we want to change to. For example, we want to change directly the socket's characteristics on the application level. So that means the socket level is socket, and then the properties that we might want to change are the sending buffer size, the internal buffer size, or receiving buffer size, or being able to reuse the address. That means the program, if your program is forcibly closed, it might have the such thing called time wait that will force your process to be hanging around, and that means another process that wants to bind to the address that we're using will not be able to do it, that will not be able to bind to it. And there are properties like keep alive and broadcasting and so on and so forth. And among them, you can only get the two properties without being able to modify them on the socket level of socket on application level, which are socket level, socket property of error and socket property of type, which I will show also a little bit later. And here you can see that you cannot set them, but you can set the rest. You can modify the rest. And get means you are retrieving that characteristic. After creating a socket, you can play with get to see the values of each of these options. And then we have other levels, protocol levels, which are Internet Protocol, IP. And on the IP protocol level, you can modify the properties that are related to the IP layer. So there are, for example, time to live, multicast time to live, loop, and so on. And you can modify them all or retrieve them all. And also the last one is the TCP on the Internet Protocol TCP. So this is like a grouping. On the left side, you can notice that this is like a grouping of the options. So whenever you want to modify some option of the socket, then you can just take a look at the beginning two letters. That means that will give you the protocol level, or you can do it the other way. You can come from the protocol level and try to remember what you can modify on which level of protocol. And the IP protocol, IP proto TCP has this kind of like keeping alive and maximum segment size. Like I told, the TCP just divides the packets, your message into segments. So you can set the segment size. You can just modify the no delay option, or how long your segment can keep alive on the network, and so on and so forth. If you want to see more details and more options, then you can just click on this link and then see more of them. So what is the function that we use to retrieve that one of those properties and then see the value? That function is called getSockOpt inside the syssocket.h header file, and this accepts the following parameters. The meaning of this function is the socket option function is used to retrieve the socket characteristic by specifying the socket level and the option arguments. So the first thing is which which socket's characteristic, which socket's option you want to retrieve to you. So you just pass that file descriptor of that socket, and then you specify the protocol level, which was in the previous slide, in this slide, the left value. So for example, you want to read the Internet Protocol's time to live. That means first you have to specify the protocol level of IP proto in this parameter, and then you have to specify the option name, the characteristics name that is defined here, the option name. And here that means after specifying the IP level, IP proto IP level, then you have to give this options name, IP TTL, time to live. And then after that you have to give a pointer onto which the value will be passed. The value of this IP22L will be loaded to this address. So you have to specify, give an address of some variable. And then this is the length of that value. And you have to specify the address of that as well, so that you knew the size of that option. And here you can see the description is in Korean. And now that we know what the get socket option function stands for, we can go ahead and try to modify it by using set socket option. So the previous function, which was get socket option, was used to retrieve the value of some option name from that socket, from the socket that we provide here. And now the next function is modifying an option in that socket. So it accepts almost the same parameters as here, but it has a slight differences, which I will show a little bit later. It also accepts the socket file descriptor of which you want to change some options. And then you have to specify the protocol level the exactly same way as in the previous one, and also the option name. After giving those, after specifying which socket you want to modify and which level you want to modify and which option, until that granularity, when you specify, you have to provide the values that you want to assign to. That's why the value must be a const void pointer option value. That means you're passing a value. The value matters. And here the value actually did not matter because the value would be overwritten. So it's a writable address, and this one is not writable form address. That means the value will be only read from this pointer, and then also the length of that option will be passed as a value, so that this function could know what is the size of this, what is the size of the value inside this address. So basically, these are the two functions that we are going to be using to play with the socket's characteristics. And I am sorry, so this should have been set. And then is used to specifying socket characteristics of the particular level, providing the option and values as arguments. So the set socket opt function is used for modifying the properties of a socket. And it will be giving the -1 result if there is any issue. Alright, so the examples are, for example, we can try to check the parameter that we provide to create a socket, which is the socket type. So this value is the type of the socket. The socket's type was, for example, here is TCP socket stream, and the next one was UDP. So we created two sockets by using the socket function call, and then we are printing out the values of these that we have provided here. And what we are trying to do here is actually before creating the socket, we already know what values we passed, but this value could contain some number, for example 1, 2, 3, or 4, and then we are printing out the values, after which we want to try to get the this property from this TCP socket file descriptor. How we're going to do it? We're going to do it by making a get socket option function call, by providing first the TCP sockets file descriptor, and then specifying the socket level of socket type. I want to just make one note that socket type was not for set socket option function call, and then here we can see that the socket type is not writable but only retrievable. that we can only make a get function call. And here in the example we're doing the get one, so you cannot do the set, you cannot modify the socket type. Now we are trying to retrieve it into socket type variable that was previously created somewhere before socket creation. So we are loading the value inside this address, and we are providing it as a void pointer, and then we are specifying the size that it can which values it can accept. For example, if it's an integer, it will be 4 bytes. And then if the get socket option provides error, which it will not provide an error because we are providing everything correctly, we will be given the socket type that was unloaded to this variable, and what we're trying to do is we're printing out the socket type 1, the value of the socket type variable that was filled after the get socket option function call. And what we have to get on this line must be matching with the socket type of the TCP socket file descriptor, which was at the beginning created with socket stream file descriptor. That means we will have the value of the socket stream on this line, and we will retrieve the same value and print out on this line. That means the socket type 1 must be matching with socket stream's value. If it is 4, it must be 4. If it is 1, it must be 1 as well. So that's what we're trying to prove it here. And then after that, what we're trying to do is, as the next line, we are trying to retrieve the same kind of socket type for the UDP socket file descriptor, to which we provided socket dgram. And we are printing out the socket type 2 as well, which must give us the value of sock dgram. And this is the output. And here, after compiling and running, we can see that the socket stream's value is 1 and socket datagram's value is 2. So its TCP is 1 and UDP is 2. And here you can see that the values are repeating, where the socket type 1 is giving us the value of the TCP that we have provided initially, and the socket type 2 is giving us the UDP's value. So that means this get socket option has worked successfully, and we can actually compile and see it ourselves by using the source code. So the socktype.c file contains that source code, so let's go ahead and copy it into the cygwin folder in our C drive. Inside this folder of your computer's username, and let's try to compile and run it. Oh, before compiling and running, let's take a look at the source code. So inside this sockettype.c file, we can see that these lines are matching with the slides, and here we can see that we have stored the variables onto which we want to store the values. For example, socket type value is used to store the integer, is used to store the value that comes out of the get socket option function call, that comes out from this file descriptor's property. So we are using just one variable, socket type, to get the option of socket type from this file descriptor and storing it into the socket type variable, and we are printing out that value. And I want to make note that we're doing the same thing here and here, same thing here, we're doing the same thing here, but instead the little difference is we're just providing the different socket file descriptors, and we're trying to get the two different values. And now let's try to compile and run this file and make sure that it is working properly and we understood it correctly. So let's compile that source file, sock type, and if we run it, I apologize, if we run it like this, then what we'll be seeing is the same thing as in the slides, that the value of the sock stream being retrieved from the file descriptor after the get socket option function call. So actually this is what we wanted to get, and if you try to play with this source file, for example, by providing socket dgram instead of socket stream, we must be seeing the same value, socket dgram. Oops, dgram. If you try to provide the same value of here and here, what we must be seeing without modifying those the rest of the lines, what we must be seeing is actually repeating 2222 values because we're only providing UDP socket type to both of the socket file descriptors. So let's try to compile the same file again and just confirm for ourselves. socktype.c file, and try to run it. And now we can see that even though here we are printing out the socket stream of 1, that was the result of printing out the socket stream itself, so that was 1, okay. But now this file descriptors socket types are just 2 and 2, because what we're doing is we're retrieving these properties that we've just passed here, which were the same to both of the file descriptors. So you can play with it yourself, provide different values and stuff. So get socket option, this was one of the examples of the get socket option function call, and now let's go ahead and see other options, other ways of using this set and get socket option function calls. And here again we're using the get socket option function call, but instead of getting the socket type, we are trying to figure out what is the size of the internal buffer that is used for transferring data. And here what we're providing is we're saying I'm still working with the the property level, the protocol level of socket, which has the option name of socket send buffer, so which gives us the size of the buffer that is used for transferring data from this local machine. And we are getting the values storing inside this SND buffer and storing the length to this variable. And after that, what we're doing is we are trying to check the receive buffer size by getting it into the len. And then we are storing the receive buffer size inside the receive buffer size inside this receive buffer variable. And so here on these two lines of code here, get socket option and the second get socket option, basically what we're doing is we're retrieving the send buffers, output buffer size, and input buffer size. So we'll have two different values inside SND buffer and RCV buffer. They might be matching, but it's okay because it depends on the machine. And here input buffer size is printing out on the first line and the output buffer size is printing out on the second line. And here we can see the output after compiling and running. The size of the buffer is 87,380 bytes, and then which is the input buffer size, the buffer size that we use for retrieving data from other machines. And the output buffer size, the buffer size used for transferring data, is actually 16,384 bytes. So we can play with this source file as well by copying this getBuffer.c file into our directory and opening up and seeing and confirming that we have the completely matching source files. Here we have the SND buffer variable and RCV buffer variables for downloading, for retrieving the this socket file descriptors to different options, which are socket SND buffer and socket RCV buffer. So if you wanted to get different property of the socket, for example, IP proto, let's say TCP, and let's say the time to live, I apologize, I don't remember completely, it was oh sorry, keep alive, for example, then what we'd have to do is provide here this value instead of this one, because this is the protocol level, IP proto TCP, and this is the option name, so we have to say TCP keep alive as here. And then what we would get inside this variable is actually the keep alive number of this socket that we have created. And we can use the same thing with set, but we'll also take a look at it later in the next examples. So now, for now, let's try to get the send buffer size and then the receive buffer size and print out like in these slides. Alright, let's try to compile the source file and see the output. So now that we can see that the send buffers, the input buffer size and output buffer size are a little bit different than the example that I showed here. The reason is it's being just run on different machines, and different machines can have different properties set, so it's dependent on the machine. So now in our computer, in our this virtual machine, the receiving buffer size, which is the input buffer size, is 65,000 blah 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 bytes, and the same is with the output buffer. So now we have confirmed that we can retrieve the socket, the TCP's, the socket's send buffer and socket's receive buffer. Now we can move on to setting those values. So now what we will be doing is we will be trying to modify the socket's receive buffer and send buffer, and then confirm that we have modified it by making the get socket option function calls. So the set socket function call is done exactly like in the previous slide that I've shown. We will be providing the socket file descriptor, provide the protocol level, and provide the option name, in this case, which is RCV buffer. So we're trying to change the receive buffer's size by providing the value using this integer to which we have already stored the value. So the value of 6144 is actually stored a little bit earlier up above. And then after modifying it, we're seeing different kind of value when we make a get socket option function call and storing back the size of the receive buffer option of the socket, of the same socket. We're using only one socket here, and getting the values here and printing out as in the following lines of code. Input buffer size is RCV buffer, which was filled after this line, and then printing out the output buffer size from the SND buffer variable, which was filled after this get socket option function call. And the output is actually right here. In order to be able to understand what are the values, we have to take a look at the source code so that we would confirm that this value was passed earlier, because we don't see it here, right? So let's go ahead and see the source file for ourselves and confirm. That is inside the set buffer.c source file, and we can go ahead and compile that source file and see the output ourselves. gcc set buffer.c set buffer, and I think we have to take a look at the source file first before running the code. So now we can see that the value is actually the values that we will be passing are stored as a variable before, and we are creating SND buffer of size 3 multiplied by 1024, and the same thing here as well. I think it will be 3072, right? And what I want to do is actually, I don't want to get the same value, so let me try to modify the receive buffer size to not 3 times 1024, instead 2 times, so that the send buffer size and receive buffer size will have different values. So here on the line number 15, we can see that we are making a function call of set socket option by providing the same socket and providing the protocol level of socket, and providing the socket option name of RCV buffer. And we're providing the value of receive buffer that we have previously stored as 2002 multiplied by 1024. And this will be passed to this socket's option as this socket's option, and this socket will have that property change, that characteristic change after this line. And then we are changing this socket's output buffer size by saying socket SND buffer and providing the value of 3 multiplied by 1024. So we will be having two different buffers changed to into different values. So, and then in the next lines, what we're trying to do is we're trying to retrieve the values that we have just modified up above and storing it inside the same variables. But instead of doing like the same thing again and again, just if you have some question, for example, we have previously stored this value right here, and if we print out, of course we will be seeing the same value. Let's just for confirmation, let's copy this one and then say resulting send buffer size and do not providing the values to it, and do the same thing for the receiving buffer size as well, just creating resulting receive buffer and not providing values here. And what we want to do with these two variables is actually here inside get, we want to retrieve the values of this socket, which is the send buffer size, to the resulting send buffer size. So now we are sure that this value, this variable is not the same as this variable, and this variable is not even initialized at the beginning, so it's 0. So, and after this get socket option, if we try to print out this rest send buffer right here, we should be seeing the property of the socket, so that must be matching with this set. So that's what we're trying to do, and let's modify the receive buffer size as well and print out receive buffer size resulting variable. So here we are retrieving this send. Okay, so what we're doing is we're retrieving the sending buffers output buffers buffer size and storing it inside this variable, and here input buffers size and storing it inside this variable, and printing out both of them in these lines. And I believe it's okay, it's completely correct. So now let's go ahead and compile this source code, the source file, and run it. So before doing it, because we have modified it a little bit, let's compile it. Alright, so before it was different, right? Before it wasn't okay, alright, let's just compile it, recompile it, and okay, let's just recompile it. So now we have compiled it, and now let's try to run it. Set buffer gives us the values of 2048 and 3072. 2048 was for the input buffer, which was the receive buffer size, and receive buffer size is 2 multiplied by 1024, and now we can see that the value is matching. Alright, now that we're done, let's move on to the next example. So the next example would be the reusing of taken address. So let me first explain you what is time wait, because we will be working with such property called socket reuse address. So regardless of server or client, both hosts go through time wait state. Because we are working with two computers talking to each other, one of them might try to finish the connection, and the response might not come in time. And this process will have to wait for closing that socket. That means the socket will be occupying the address port, and port cannot be bound to another socket unless it is disconnected. So that means we will be going through the time wait, and that might range from 5 seconds to, I believe, 30 or something seconds. It will be a long time. And then the address cannot be reused, and here you can see that this host A is going through the time wait state, and the host A will not be able to launch another process that could use this address, because this address is taken up by the previous socket that wasn't successfully closed, and it is going through the time wait state. That might happen regularly when you're working with multiple clients, and then one of the clients forcibly close, or the server forcibly close, the process doesn't exit successfully, and then the socket will be left open. We can set the bound address or port to be reusable by another socket. That means it will be just skipping on while the server tries to bind to that address that is still going through the time wait state. It will just skip that time wait state check, and then it will just occupy that address instead of waiting. So it's like fault tolerance, so we can understand it like a fault tolerance. So what we'll be trying to do is we'll be trying to give a value of true, a value of 1 to this property of our socket, and that will be very simple. And the option length will be the length of this option variable, and the option variable is actually the value true, and that will be the equal to 1, which will be defined a little bit early, before these lines of code, and I will show that in a code as well. And so we will be modifying the server sockets. This socket's property of so reuse address. And I want to remind you at this case, it's just one of the example cases where that can show you what is the use of set socket option and get socket option. So this can be used to handle some of the issues that are real world issues. For example, FTP, the file transfer protocol, use reuse address because sometimes it goes through some forcible process kills. And now, when we set the set socket, when we call the set socket option by specifying this characteristic, this option name of reuse address, and provide the value of true, this socket will be able to bind even if the socket is going through the address is going through the time wait state. That address will be still able to bind. And I will show it as an example. I will show it in a code, but before I wanted to tell you that this is somewhat working on my virtual machine without any issues, without any binding issues. So that's why I will be, it may be because it's the virtual machine and we're using CYGWin terminal. If you try to do the same thing that I will show in an example in a real Linux environment, or in your Mac, like I will show, you will still see the bind error. Also, there are cases when socket reuse error property of socket is set in socket programming, for example, FTP. And you can just try to Google the use cases and you will see some higher level internet protocols, including FTP, require you to keep reusing the same port number. Okay, because again, about the issue that can occur if you don't do it, sometimes it's not required, but some of the protocols require it. What you will be forced, what kind of problems you'll be forced is, for example, those connections who were forced to close but failed to close will hold the TCP port in time wait state for 30 to 120 seconds. I apologize that I said 5 in the beginning because I do not remember the specific numbers, so here are the specific number. From 30 to 120 seconds, it will be just stuck inside the time wait state and you cannot bind to that address. And you can see this one as a solution by specifying the socket reuser address value of 1, value of true. So let's take a look at this example, which are these two source codes, these two files, echo client and the reuse address server. So these files I have also loaded inside this Mac, and I will show this as an example inside this Mac environment. And you can just do the same thing in the Linux environment as well. And maybe you will have the same issue in your machine in your computer as well. Maybe this is because I'm using virtual machine. So this reuse address is what it's doing is actually we have the reuse address server. Let me open up the Echo client as well. What the server is doing is it's just opening up a simple TCP server here, creating the socket, and I'm skipping these parts of code where we are setting the reuse address to true, because I want to show you the problem first and then show you that this resolves that kind of issue. And here, let's say, let's continue. The socket is created just like I've explained in the previous sessions. Just we are saying we want to listen to any address in any interface. We're just providing the port numbers and addresses that we want to bind to. And at this step, what TCP does is actually it checks. What application does is it checks if the bound is able to that address is able to be bound inside by this function call. And if that address is going through a time wait state, if there is any socket that's going through that time wait state, then what we'll be seeing is we'll have the bind error case, which must print out this function's output, which is just printing out the message. So what we should be seeing is this bind error case in a problematic case. And then if everything goes well, if everything is going well, then what the server is doing is just accepting one client's connection request by making an accept function call after binding, and then after listening, I apologize. First we're listening for a client, and then we are accepting and at this point we have the client socket option open, and then we are just writing back the message that the client is sending us. It's just the echo server, but for the sake of this example, so it's just an echo server example. Apologize, I am low on charge. So basically this is the echo server example, and the echo client is the same TCP echo client that we have been trying to create in the previous lab sessions. It's just simply trying to create a socket of TCP socket, and then trying to connect to a server that we specify in our arguments, and just providing the address like I've explained before, and then just trying to connect to that address, and then do the echo server client communication inside this while loop by getting the message from the command line, and then checking if the user wants to quit the program, and then sending, if user doesn't want to quit, sending that message to the server and receiving it back, and then printing out that message in here. So it's basically the echo client and echo server example. So let's first see that echo server and echo client working. For that, what I will be doing is I will be opening up two command lines, and then compile and run those two client and socket, client and server. So on the left side, what I will be running is the server code, the echo server, and here the client. And I want to make a note one more time that we are not actually dealing with the set socket option function call yet, because first I want to show you what kind of problem there could be. So that's why it's just a simple TCP echo client and echo server example. So here let's try to compile that. Okay, first I want to do something else. You don't have to do it. Okay, I just want to minimize it. Echo. This is not for your case. Oops, not echo. Sorry. So this one is going to be running our server, and this one is going to be the client. So here, let's compile the server code. GCC reuse. Oh, first I have to go to desktop. I apologize for not being completely prepared at the CD. Okay, so now let's try to compile the server part. I made a mistake again. GCC this and server. So now what we have is the server executable right here, and now we want to compile the client executable as well, this echo client to an executable as well, by calling GCC echo client-o client. And now we have the client code here. So now what we'll be doing is we'll be just testing if the echo client and echo server is working fine. So first let's go ahead and run this server by providing 4444 as a port number, and here trying to connect from the client side to this server 127.0.0.1.4444. And now that we can see that the client is connected, we can just go ahead and see that this server is doing what it's supposed to do. It has a job of bouncing back the messages that it's receiving. It is sending back all the messages that it's receiving, like it's an echo server example. So it is working fine. And then now, if we do quit from this side or from the server side, it will be still okay, and then we can still run the server one more time, and then we can still connect it and just behave normally. And even if you stop it here with the client's Control-C, if you try to force close that server, you will not be able to bind it again. And now that in the previous example we've seen that even if you if you close the TCP connection normally, your server will be able to bind it one more time after this run. But now that we have just forcefully closed the process, we cannot do binding because that TCP is going through time wait state. After a little bit of while, like after 30 minutes or so, after 30 seconds or something, you will be able to reuse that socket, that address port number as well. But now let's try to generate the same problem again on the port of 44445, to which we will be able to bind now, and then connect to that address on the client side. Oh, we cannot even connect to it. So because I tried to connect to the previous port, I couldn't. So now let's try to connect to the port number of 44445. And now that client is working fine, what we'll be doing is we'll be making sure that this port will be also going through the time wait state, just to validate that this is being caused because of forcibly killing that server process. For that, what I will be doing is I will create one more command line. Oh. And then I will try to kill this process. I will try to forcibly kill this process, which is just as simple as Control C, the stopping. What I will be doing is I will get the this process's ID and try to kill it from here. So what I will do is kill 58006, and if you click it, you will see that this has been terminated. That means it has been forcibly closed. It didn't terminate correctly, and we can see that this client is still here and it is stuck. So now if we try to bind it, we will see the same issue coming up again. So now that the port number 4444 has become, we can see that this has been causing us a little bit of problem, because our server could not bind really fast, like right after that it was forcibly closed. It was let's say if this server is your server, for example, handling authentication or something, users will not be able to authenticate. For example, here, if you'll try to connect to that port number 44445, the server will not be working. 127.0.0.1, 4444, the 4445, it will not be able to connect, even though it is the socket is still open. It's not completely closed. So now let's try to solve that issue of binding. First, let me gracefully close it with Q. So now both of the ends, the server and client, has gracefully finished. We don't have any problem with the socket, so we can still bind to the port number 4444. But what we'll be trying to do is, actually, we will be modifying the server to be able to bind, even though the server, the address is going through the time wait state, by making call to this function of set socket option and providing the reuse address variable and setting the option to true, which has the value of 1. Alright, so let's comment these lines out. So now what we're doing is we're saying, before binding, make sure don't check if the address is going through the time wait state. Now we can just close these source files and try to compile it one more time. GCC reuse address -o server, and again GCC -o. We don't actually have to compile the client, but let's do it. Just client -o client. So now we have compiled the reuse address server that contains the set socket option of reuse address set to 1, like right here. What we are trying to see is not seeing that bind bind error text, but instead it should be working fine, even though we kill it forcibly with the third terminal. Right here, we're trying to kill it with just like we've done from here by the ID. Okay, let's run the server first on the port of 4444. So now we can see that the port is free and we can connect to it and work fine. And now client is also working fine. That means the socket is able to communicate with, the server is able to communicate with the client, and client is able to communicate with the server. Now what we'll be trying to do is try to get the same kind of force closing of the server so that we would see that bind exception. But the difference is, again, we set that we don't want to check the time wait state in our code. So that means it should have resolved. So let's try to kill that process, which is server, which has 58175 kill 58175. So the server has been terminated. And now if we try to, so we don't need the client, or just, if you try to run the server again, you don't see that bind error. And then if you try to connect with another client, if another client tries to connect to the server, for example, by calling client 127.0.0.1.4.4.4.4, it will be able to still communicate because the server is not checking the time wait state. So this is just one of the examples of where the sockets property sockets options can be modified to resolve some kind of issue. So what you could do is take a look at this table one more time and then try to play with them, with the ones that you can change and with the ones you can just retrieve. Thank you for listening. I hope to see you soon.